Hi, everyone. So my name is Uri, and I'm a core developer at Meteor, and I'm also the weird guy from yesterday's keynote. So I also wrote, before I used to be a Meteor developer, I used to be an Angular developer since the happy 0.9 days. So the fact that Angular 2.0 is in alpha is not really scary for me. And later on, I wrote the Angular Meteor project, which actually I started before joining Meteor. And I'll talk a bit about that project as well today. So in yesterday's keynote, I talked a little bit about that concept called the connected client architecture. And today, they've given me a little bit more time so I can dig more deeply into it and why I think this is a very important point that you should get from this talk and from this conference at all, and you should get that point to your own stack. Doesn't mean if you use Meteor or not. Then I'm going to talk about Meteor itself and the relations to Angular and Angular 2.0. So what is the connected client architecture? So in recent years, we all know about it. The web has changed. Our mobile apps, our web apps are now apps. So they're using mobile UI. They're not using pages or less than links and forms. They're more like a modern UX and UI. We use it on mobile. There's no refresh button. The user is not hitting refresh anymore. And we know all about it, right? We use Angular, and our modern front-end frameworks are already adjusted to it. But the thing is that those types of apps that are actually, this UI and this change started from the large players in the industry, right? Like the Facebook web app or Gmail or applications like that. They use a different type of architecture. And they don't use a restless server, a stateless server with a request response. They use a stateful server with publish, subscribe. And somehow our front-end frameworks until now try to compensate on lacking those and us working on REST types of backends. But we are still missing this type of connected client architecture. And the thing is that our clients need this type of our users need this type of architecture. They expect that even if they can't verbalize it. So what is a connected client looks like? So first of all, the backend of this connected client architecture needs to push live updates from the server all the time. So it's not like the client is sending a request and getting a response. It just updates in real time all the time. The second thing is that when a client makes an update, like let's say a like button on a Facebook page, you don't have a spinner. You don't send an HTTP call and wait for a promise and then respond to the user. The user will leave your website today. He expects more. So with Facebook, the like is happening instantly, and then when it goes back to the server and the tough syncs happens, the user don't care about it. So even if he clicked now on like, and now there's 2 likes, but in the meantime, there are 30 other likes on the network, the Facebook infrastructure will take care of that. And right now, your backend servers don't do that. And if you are doing that, you're doing a lot of work. The third thing is that you want this new type of experience. You want it on all the devices. You want it on your watch. You want it on your mobile device, and on your IoT device as well. Our users don't want to wait for spinners anymore or for request response. So how does Meteor fit into all this picture? So Meteor is based on three big concepts. One, Meteor is a framework. It's a completely open source framework that it's built on that type of architecture, and I'll show that in a second. The second thing is Meteor is built on the concept of JavaScript everywhere. We are in a point that we can write JavaScript anywhere, and more than that, it's the only language that can run anywhere. So if we're going to create a platform that truly solves everything for us, we have to write it in JavaScript. And the third point is that this is a complete open platform. It means that it takes care of everything for you, but it's still open source and decoupled if you need to change stuff. So I'll dive a little bit into each of those concepts. So about connected client architecture. So the first thing we need is to push updates all the time to the client every time a change happens. Now, if we're writing it today on our own servers, we would need to somehow recognize that there was a change in the database and write a lot of manual work to then propagate this change to the client. But with Meteor, which was built by engineers that came from Facebook, Asana, and Google, this type of architecture is built in from the start. It means that on every layer of the platform, there's something that handles that. And I'll just touch on a few meaningful points. The main thing, if you're working on the server, is live query. So instead of now, you can think about it as kind of like watch on the database, $watch on the database, but in a performant way. So you can just define your database query. It can be a Mongo query or a SQL query. And then this query will self-update it. It will notify when something is changed on the database. And it doesn't matter if this is a change from your app to the database or a third-party change from another server to your database. So it saves tons of code for writing and tons of potential bugs. And it's kind of like the way Angular changed the jQuery world. So that's live query. And this is just one concept that exists in Meteor and in your, probably in like regular REST type of applications, you don't use that. Or you need to write one yourself. Second concept is synced client cache. So synced client cache is hides behind that concept like two different like jobs that you need to do. The first thing is to propagate those changes from the live query to your applications. And in Meteor, you can actually, you can write, like you wrote your query just once on the database, it will automatically propagate this data with publish subscribe to your clients with one line of code. And you can obviously change it and expand it, but the thing is that this cache will sit on the client, and it will save you a lot of code for writing syncing services and all kinds of stuff like that. And think about it, that if you were working as a front-end engineer at Gmail, you would expect to get this type of infrastructure. A front-end engineer at Gmail never calls an HTTP request and waits for a response. He has an infrastructure team that takes care of that for him. And that's the same thing here. The second thing that connected client we talked before that needs, it's if I'm now pressing the like button in Facebook, or if I'm writing a draft in Gmail, I want it to happen instantly, but I don't care about network latency. I want it to save instantly. And there's a lot of syncing and tough syncing mechanism that I'll show in a second that you don't need to do if you have this infrastructure ready. The second concept that Meteor is wrote about is JavaScript everywhere. So Meteor takes care of your server, your web clients, your mobile clients. It connects to an IoT devices and also to watches. And in all of those platforms, Meteor runs JavaScript. And that's the only language that you can actually use. So Meteor is built on JavaScript, and it's also completely open source. If you looked at the connected clients that we talked before, some of that code already exists, like the front-end code, and you probably heard about Flux and GraphQL and Relay. So some of that code is being outsourced, open source from the large companies, but none of the large companies is going to open source the backend infrastructure. So Meteor is your open source backend infrastructure for that type of infrastructure. And you should understand that your users demand that infrastructure, even if they don't know that, because your user use Facebook, or they're sharing photos on Instagram, and they don't care that you are a small development team. They want the same experience. So if we combine, let's say, just for example, we're combining two concepts. One is the completely isomorphic JavaScript, that you can run really JavaScript everywhere and use your code anywhere, with optimistic UI, which optimistic UI is the concept that I talked about, the like button, where you press like and it happens instantly, and then later handles all the tough syncing latency compensation with the server. So how does it look? So everyone is talking about isomorphic JavaScript. Like we can write JavaScript everywhere and everything is fine. But when you actually work on the min stack, for example, then you have your particular user has a different name on the DB. It has a different name on the server and the network, and it has a different name on the client. So you can't really share code with that. You can maybe share some util code or something like that, but that's not working, actually. But with Meteor, you can actually, the API is the same throughout the stack. So it doesn't matter on the database and on the network and on the client, it's the same code. So I can really use the same language, the same database API, and I get true isomorphism. I can write any method, and I can run this method everywhere. And this is fun, and this is nice, and it maybe saves some time in when you write code, but the true way that it comes to, that it makes a difference, it's when you combine it with the syncing mechanism and optimistic UI. So just an example, let's think that right now we are clicking on the like button. So we clicked on the like button, and then we execute this method that's called +1 or something like that. And this method we write it once, but it runs both on the client and the server. And when it runs on the client, it's happening instantly, and it just adds from, I don't know, let's say we had 2 likes to 3 likes. And then it updates the UI instantly. And for the front-end framework and the front-end developer, that's very easy, because you don't care about promises or something like that. It's a local database. So it happens instantly in real time, and you just now have +3. But now the same thing, the same request comes to the server, and the server runs the same method. We wrote this method once. And when this method runs on the server, then let's say maybe I don't have permissions to do that thing. Or maybe while I was clicking the like and there was a latency on the network, there was 30 other users like adding a +1, or maybe blocking my post, or I don't know what. So Meteor will take care of that for you. What doesn't matter if what you did was exactly the same or there was a problem on the way, Meteor will then send the right data from the server to the client, update the local cache, and get you the real UI. And for the user, it just happens. And if you look at applications like Inbox or Google Plus or Facebook, that's what's actually happening. And you can write those stuff yourself, but think about how many edge cases you would need to handle this complexity. The Gmail infrastructure team and the Facebook infrastructure team are really big. So if you are going to do that for yourself, you need to understand that it's not as easy. Now, like I said, it's not easy, but the actual code is very similar between those cases. And if you look at the strategy that Gmail uses and the strategy that Facebook uses, it's pretty similar. So Meteor, and you can write those stuff yourself, but Meteor is doing that for you out of the box. And it's completely open source, so you can change everything inside, but out of the box you get a complete platform that works for you. And when you think about it, most of the code today is not written in Node, not yet. Most of the code today is written in .NET and Java. And the reason is because those are platforms. When you write .NET code, you expect most of the stuff to work together out of the box, and then later you can change stuff. But the problem is in the JavaScript ecosystem, we don't really have something like that. Everyone likes mix and match stuff, and that's good. The JavaScript ecosystem is amazing, but if you just want to write your code, you don't want to do this mix and match all the time. I mean, every second day there's a new build process and a new thing, and you don't have the time for it. So we need a JavaScript platform. And the JavaScript platform needs to be built from small parts that are loosely coupled, but out of the box, that works great. And someone is taking care for you, like an infrastructure team that takes care of all this infrastructure working for you. And that's Meteor. And the difference between Meteor and .NET and Java is that Meteor is also, because of the power of JavaScript, runs everywhere. It takes care of everything you need from the mobile and everything from the mobile and IoT devices, but also based on what I said before about the connected client architecture. And your users want that. Then your next project will probably be a connected client project because your users expect that. So Meteor is also not a new thing anymore. It's like just recently it became the first, the highest rank on GitHub as web application framework. So it passed Rails on GitHub, like their home ground. And there's over 200 meetups, and there's like over 7,000 community packages. And if you look at, I hate those graphs, but if you look at the trend graph, when I started using Angular and I tried to explain to people that Angular is going to be big, I always looked at the trend graph because it was very unpopular to use Angular at the time. And if you look at the trend graph of Meteor, it's the same. So how does Meteor relate to Angular? Like it's the same thing, or some people ask in the forums, like, is Meteor better than Angular, or Angular better than Meteor? So the Meteor is a platform, like I said, and it's decoupled. It has decoupled parts. So you can actually use Meteor with React. You can use it with Angular 2.0, with Angular 1.0, or with Blaze, and you can actually mix and match them all together. So when I started the Angular Meteor project, my goal was to make Meteor like a first-class citizen in the Angular community. So everything that's happening in the Angular community, Meteor should be part of it. And it wasn't easy, but I think I can say that today we are there. The first thing is that anything you want to use that you use today on your Angular 1 applications, you can use with Meteor. You can use Ionic, you can use Firebase, you can use UI Bootstrap, or anything you want. So that's one thing that we are with the community. But there's other stuff that we actually, I think, lead the community and help the community around. So last week I released a blog post and a tutorial about writing a WhatsApp clone in Ionic, Angular, and Meteor. And I truly believe that this is the fastest way today to write mobile applications. And you can check it out. It's on the Ionic blog. And the second thing we've done, and we help the community as well, is that one of our community members named Paul wrote 6 months ago Angular 2 now, which is, you probably heard about NG upgrade that you're probably going to soon be able to use. We are using Angular 2 now for 6 months already. And it's basically the same concept. You can use Angular 2 syntax, and I showed that on NG Vegas like 6 months ago. You can use the Angular 2.0 syntax today on your Angular 1. And Paul was part also of the NG Forward team. But what's really interesting is Angular 2.0 Meteor, because Angular 2.0 is built for this type of architecture. Angular 2.0 is built to support large client applications that require this type of infrastructure, and it works great with it. So the integration between Angular 2.0 and Meteor is really exciting. The first thing is that it's probably the easiest way to start Angular 2.0 application today. The only thing you need to do is go on the Meteor platform and do Meteor add Angular 2.0. And that's it. And you'll get all the dependencies, and you get the build process, and you get everything you need out of the box. No gulp files and no any other files. So that's one thing. Now, the second thing is the infrastructure itself. So the integration was so much easier to write, and it's so much easier to learn as well. Because in the integration that we build in the new Angular 2.0 Meteor package, we don't use pipes or observables. You can just write regular Angular 2.0 code, and it looks the same way, and it just connected to a Meteor collection. And that's a good thing also on the Meteor side, because on the Meteor side, you write pure Meteor code. There's no connection code and no everything. And I'll show that in a second. And the way we were able to do that, instead of letting you write observables and use observables and pipes, which are nice but sometimes hard, we actually, because of the power of Angular 2.0, we were able to link into the defer process, to the change detection process of Angular 2.0, and let Angular 2.0 know about the changes that happen because Meteor already knows that. And that's what made the integration super simple, but also super fast, like I showed yesterday on the keynote. So I'll show really quickly how it looks. So I have a, do you see my, no, sorry. Okay, so what I have here, and I'm not going to live code today because I don't have the time, but this is probably the same types of application that you saw me write on NG Vegas. Every time it's parties, so same thing. And this is just a regular app, and I can, let's say I'm creating a new party in London, and it will sync instantly between all the clients. That's fun, and you saw that already in my previous demos. But the interesting thing is to look at the code. The code that I have here, the Angular 2.0 code, looks exactly the same like a regular app, but the only difference is that I'm bringing my collections here with imports with TypeScript. And you see that I'm using TypeScript on Meteor. You can use TypeScript both on the client and both on the server. And in our tutorial, we actually do that. We use TypeScript on the client and on the server. And then the only thing I need to do is to say that parties is a Mongo cursor. And that's it. And in the constructor to fetch everything. And from that point on, I don't need to do anything. You can look at my HTML code. There's nothing Meteor in here, and there's no pipes and no observables. So this is like the, I don't know, like the simplest to do that you get on the Angular tutorials, Angular 2.0 tutorials. So this deep integration, I think it's very valuable. So going back, so this integration was possible with the work that we did with the Angular team. And you can actually, again, like you don't need to trust me. You just need to go to angularmeteor.com. There's a tutorial that I already built for Angular 1 Meteor. But then I took the same tutorial, and every step that I've made, and it's a full, complete tutorial with like 21 steps with Ionic and users and permissions, and it's complete full stack app. And basically, step by step, I converted it to Angular 2.0. So you can actually go to a step 5, and just compare Angular 2.0 and Angular 1. So just, you need to check it out. And I think the most exciting thing about writing this Angular 2.0 Meteor package is the collaboration and the work that we did with the Angular team. I spent a bunch of time with them, and they helped me a lot. And tapping into the change detection mechanism was easy, but they helped me a lot with it. So I'm just very excited about like the road ahead and our work together to make this type of stack available for everyone. And it's already available, so you can just start using it. And I think that all the stuff that I showed you today, I can safely say, and some of you probably gonna be mad at me of saying that, but I really think that Meteor is the best backend for Angular apps, for all the reasons that I told you today. So what are the takeouts from this talk? First thing is that there's a backend revolution happening. Angular did a huge revolution in the jQuery world, and it was an era of change. But if you look at what Meteor is doing on the backend, it's the same thing. It's like what Angular did to jQuery world, Meteor is doing to the DB and to the server code. And the same thing is what Rails did for REST type of application, that it used to be very hard to write REST type of applications, but then it became a standard. Meteor is doing for the connected client application. So, and it just passed Rails. And the second point is now is the time to become a full stack developer. The opportunities that Angular gave you when Angular came out, Meteor is giving you right now on the backend. So you should take out that opportunity because there's more and more teams and jobs that it's one team that does the backend and the front end. And your next app will probably be a connected client app. You can write it with an all backend and try to simulate everything yourself, or you can use an infrastructure that is built out of the box for that. So that's it. The only thing you need to do to get all this information is just Google Angular Meteor. And thank you so much.